So here I have the chloride ion that's shown within this structure here, and I want to emphasize now on how important it is within these different residues on how this chloride ion actually moves through the transmembrane protein. So first, before the photoisomerization even occurs, the chlorine ion is ionically paired with the Schiff base, which is shown here in blue, right here in this section. And following the light activation, the NH bond of the Schiff base flips, inverting the alignment of its dipole moment relative to the threonine 85. The flip elevates the energy of the bound chloride due to the increased electrostatic repulsion with the NH dipole and the carboxylate of aspartate 238, which is shown right over here. From Colby et al., which is one of the sources we used, and through their method of FTIR spectroscopy, we can see a change in the presence of PSB, the protonated Schiff base, and the arginine 108 located here, that results in a loss of the arginine's 108 chloride interaction. And this is important because we can start to see the weak interactions and how it forms to go down the transmembrane protein. And it actually goes down through the hydrogen protons that go through that water fire brigade as we discussed earlier. And that's actually a way that chloride moves through. And now we also have serine 115, the single serine that is actually very instrumental in keeping the chlorine solvated. Now as the chlorine of course moves through the transmembrane protein, it is not clear to find where the final position of this of the chloride is before it leaves the transmembrane protein, but we can assume based off of the studies shown that H bonding to the hydroxyl of the threonine 203 and individual water clusters help to stabilize that chlorine before it exits out the transmembrane protein. What's important about all this is energetics have shown that the chlorine ion is held 18 angstroms below the membrane surface by a combination of these ion-ion and ion-dipole interactions. This ion movement across lysine 242 and the chromophore retinol, this protonated Schiff base, explains that mechanistic similarity that occurs between chloride ions as well as proton movements between rhodopsin structures within the rhodopsin family that can be compared between bacteriorhodopsin and halorhodopsin.